Welcome to Chapter 7, Section 3. If you hear any noise in the background, it is my dog that's walking around somewhere off camera. More parallelograms. So how do you know you're looking at a parallelogram? You're looking at a quadrilateral, 4 sides. How do you know that it's a parallelogram? Can you prove it definitively? So turn to page 376, copy down theorems 7.7 and 7.8. Pause the video to do that, and then meet me on page 377, number 1. Okay. In quadrilateral, W, X, Y, Z. So first thing we're going to do is we're going to draw the quadrilateral. Now, I'm going to draw something that's close to a parallelogram, but maybe it's not. Figure is not drawn to scale. W, X, Y, and Z. You should be drawing it too. Remember, the more you draw, the better idea you get of what we're doing. We know, and by the way, W, X, Y, Z, remember you always go in order around the parallelogram or quadrilateral. It doesn't matter where you start, as long as it goes W, then X, then Y, then Z. The measure of angle W is 42 degrees. The measure of angle X is 138 degrees. The measure of angle Y is 42 degrees. We want to find the measure of angle Z and then find out if it's a parallelogram. Well, this is a quadrilateral. All angles in a quadrilateral need to add up to 360, or if you don't remember that, 4 sides take away 2 times 180. So 2 times 180, 360 degrees. So what do we got? Let's see. Using my calculator, you can do it yourself too. 360, take away 138, take away 42, take away 42, and we're left with 138 degrees. So the measure of angle Z has to be 138 degrees, and good luck. Good news. What luck? We have opposite angles being congruent. Therefore, we know that, yes, it is a parallelogram because of the opposite angles converse theorem. Okay. Go ahead and turn to page 378. Pause the video to copy down theorems 7.9 and theorems 7.10. Make sure you draw them as well. Even though they might all seem logical, the whole point is that there's small differences in knowing how it's parallelogram. So pause the video to copy that down, and then meet me on page 379. Okay. You should have already copied that down, unpaused it. We are going to do number 2 at the top of the page, and you're going to draw it with me. So nice that they draw it for us, but too bad, so sad. You need to draw it to get a good idea of what you need to do. All right, pause if you still need to continue drawing. Let's make sure we read the directions. What values of X and Y, excuse me, for what values of X and Y will this quadrilateral be a parallelogram? Explain your reasoning. Well, if I want it to be a parallelogram, I need to use the opposite angles converse, which means if I can get these opposite angles to be the same, to be congruent, I can make it a parallelogram. So let's do that. I'll start with the X's. If only 3x minus 32 could equal 2x. If only. So why don't I take away 2x over here, move 32 over there. So 3x take away 2x is 1x. And if I add 32 to the other side, I get 32. So x will be equal to 32. 32. If x is 32, angles A and C equal each other. So I just need to also make sure that 4y equals y plus 87. If these two angles can equal each other and these two angles can equal each other, I made this quadrilateral or parallelogram with the opposite angles converse. So I'll take away y to both sides. And 3 goes into 90 30 times, so it goes into 87 29 times. 3 goes into 90 30 times, but that's 3 too many. How many 3s too many? 1 3 too many. 30 minus 1 is 29. Mental math there, munchkins. So using, I'm going to say it again, the parallelogram, actually, let's not even use that. I'm trying to be lazy, but it doesn't work. Opposite angles converse theorem. That's good shorthand right there. Opposite angles converse theorem. If this is x and this is y, this quadrilateral is this quadrilateral is a parallelogram. I need to turn my page, but we are still on number 3, page 379. Okay, draw it out, and then we'll read the directions. Okay, the directions say state the theorem you can use to show that the quadrilateral is a parallelogram. So, move my calculator somewhere. So I have more space. Okay, what do we have here? We have opposite sides that are congruent because they're the same length and they're parallel. So is there a theorem that talks about opposite sides being congruent and parallel? Yes, there is. Looking at page 378, which we copied down, theorem 7.9 states that if the opposite sides are parallel and congruent, it's a parallelogram. So what's the theorem? I'm going to use the opposite sides parallel. We can use the parallel symbol now. And congruent theorem. All right. Again, we're nitpicking in this case, and that's important. We're making sure our details are correct. Let's draw number 4, and then let's pick the theorem. Once we draw it, we have a pretty good idea of what we just did and what we're looking at. Okay. I have all opposite sides congruent. I see nothing about parallel lines. All I know is that opposite sides are congruent. Is that a theorem? Well, turn back to theorem 7.7. Indeed it is. It's the opposite sides, converse theorem. Opposite sides converse. If I know that the opposite sides are all congruent, then it is a parallelogram. Let's do the same for number 5. Let's draw it. That'll help us understand what we're given. And then we can determine how we know what we're looking at is a parallelogram. All right. So I drew it. I only know about the angles. I can see that opposite angles are congruent. Is there a theorem that tells me that if the opposite angles are congruent, what I'm looking at is a parallelogram? Of course there is. It's the opposite angles converse, which we used actually previously. And then it's theorem 7.8 if you don't believe me. Okay, last one, everybody. The directions say for what value of x is the quadrilateral MNPQ a parallelogram? Explain your reasoning, in other words, why. All right, so let's draw it. Oops, figure not drawn to scale. I thought I was doing pretty good here. That's okay. Oh, we have some diagonals. We know that's congruent. I'm guessing that 2x refers to this part of the diagonal because They aren't trying to trick us. And they're telling us that this part of the diagonal is 10x minus 3. All right, so for what values of x is this quadrilateral a parallelogram? Well, if in fact, and I know the diagram's pretty bad, but if they are talking about this part of the diagonal being 2x, then this part of the diagonal and this part of the diagonal need to be congruent for this to be a parallelogram. So that means 2x needs to equal 10 minus 3x. So let's add 3x to the other side. We get 5x equals 10. Let's divide by 5. Okay, so x equals 2. Explain your reasoning. Oh, is there a theorem where we just talk about diagonals? We know that this diagonal is being bisected by this diagonal, right? It's being split into equal parts. This diagonal is chopped equally by this diagonal. Is there a theorem about the diagonals? Of course there is. Look back at page 378. It's the parallelogram diagonals converse. Okay. So these two are our answers together. Remember, when it says explain your reasoning, make sure you at least know why you know it to be true. All right, last thing you need to do to help you out, at the bottom of page 379, copy down that concept summary, okay? I'm sure most of you are sitting here thinking, duh, we just make it equal when it looks like it needs to be equal. Great, but now why? What part of the parallelogram or the quadrilateral tells you what you know? All right, so copy that down. And of course, you'll have some practice and ask me in class to clarify anything that you need.